In this lesson, we're going to talk about congruent. First, what does congruent mean? Congruent just means figures that have the same shape and size are said to be congruent. So if I give you two triangles that are like essentially the same, we're going to say these two things are congruent. And that's a symbol for congruence, like that. So it's like an equal sign with a little tilde on top of it. So it lets you know they're congruent. Congruent transformations, that's any transformation that preserves the shape. So we call them reflections, right? If you reflect the triangle, it's the same triangle still. Translation, so if you move it, same picture. Or rotations, right? If you rotate it. These are also known as isometries. Those are all congruent transformations. So if you do them, you don't change the shape at all. So they're still going to be congruent. A congruency statement just lets you know the order in which things are congruent. So if I say AB is congruent to CD, that lets me know that, hey, A is congruent to C, and that B matches up with D. So that's a congruency statement. So the order matters is the general idea there. Let's use that to talk about congruent triangles. So here's two congruent triangles, and we have our congruency statement right there. And remember, order matters. So this right here tells me everything I need to know. So angle A is going to be congruent to angle D, like it says right here, right? So notice how they both have one curve. Lets you know they match, right? Angle B is congruent to angle E, just like it says, right? And they both have 2 marks, let you know that they go together. And then angle C goes with angle F, right? All from the congruency statement. And it works the same thing with sides. So if you look at here, side, let me erase this. Side AB should go with side DE, like it does. So AB, 1 mark, goes with side DE, 1 mark. Right? Likewise, you can do the last two, BC, EF. BC goes with EF. So BC goes with EF. And remember, the marks let you know how they correlate. So like here, AC is going to go with DF because they both have 3 marks. You can see it down here. You can see up here also, right? AC, first and last, goes with DF, first and last. So that's how you could read a congruency statement and this for triangles. And keep in mind, corresponding parts of congruent figures are congruent. So if you have two triangles that are congruent, then all the corresponding parts, like AC, all the things we talked about, they're going to be congruent. Okay, let's do an example. I'll give you these two pictures here. I'm telling you triangle JKL is congruent to triangle MLP. We want to name all the corresponding angles. Now, if we just look at the pictures, they are reflected, so it's not going to be exactly just as these normal. But look here, right? Angle J goes with angle M, so J goes with M. So angle J is congruent to angle M. Notice I wrote an angle symbol and I wrote a congruent symbol. Next, K goes with N. So K up here goes with N right there. So angle K is congruent to angle N. And then lastly, right, the last one has to be together. So L has to go with P. Angle L is congruent to angle P. Corresponding sides work much the same way, right? So if I look here, it might be a little hard because these are reflected to figure out which ones, but see how JK, how it's between the one symbol and the double symbol? So it has to match with the same thing here, right? Between the one angle and the double angle symbol. So JK is congruent to MN. And let's see if I wrote that correctly. Remember, JK is the first two, MN, first two matches properly. The single angle mark matches the single angle mark, and the double angle mark matches the double angle mark. Okay, next one, I'm just gonna use a congruency statement here. KL goes with NP. So KL is congruent to NP. KL is over here, and NP is right here. So those match. And then lastly, right, we have JL is congruent to PM, actually MP. All right, order does matter. So if I do JL first and last, has to be first and last MP. So these match. And that's how you use a congruency statement. Here's the same thing, but using a polygon, quadrilateral to be exact. Now again, this is still the key. The congruency statement is still the key. So if I want AB, right, let's go angles first. Angle A is going to go with angle E. You can see from the markings, angle A has one mark, and angle E has 1 mark. And the same goes with the rest, right? Angle B goes with angle F, angle C goes with angle G, and angle D goes with angle H. We can do the same thing with the sides, right? AB goes with EF, you can see the marks. CD is going to go with GH, so CD is over here, GH is over there. And then you can do all the combinations. Like you want to do BC, that's going to go with FG. So we're going to end up with the same thing there. So that's how we use, again, how we use corresponding sides. Okay, third angle theorem. All this says is if you have two triangles with two angles congruent, like see how angle B is congruent to angle E and angle A is congruent to angle D, then the third angle must be congruent. So you don't actually need to show the third angle. We just know, oh, they must be congruent. And that works because a triangle is 180, right? So if I say this is like 80 and this is 60 and this matches over there, well, if we do the math on it, 180 minus that, we're going to get 40. And we do the math on this one also. Because the triangle, we're going to again get 180 minus 60 minus 8, just like we did over there. We're going to again get 40. So that's why you only need to show two sides congruent. Because if you just show two sides congruent, and then by math, we know the third side has to be congruent. This concept's going to come up a lot when we start proving that two triangles have to be congruent. So that'll be like a later lesson. But that concept will come back again. And finally, let's do a little check. Do we understand? Name the congruent figures by making the congruent statement. The first figures here are kites. And if I wanted to say the congruent, it's going to be A, B, C, D. I mean, you can start anywhere. We'll say start at A, B, C, D. And that's going to go, since it looks like it got rotated, A would go with E. So it'd be E, F, G, H. So A, B, C, D is congruent to E, F, G, H. So remember, order matters. Now we go on to this one. We have to figure out the ones that match. So this first one here, A, B, C, D, it does not look like it matches with that one. It does not look like it matches with that one. It looks like it's this one. It looks like it got like rotated this way. All right, so we're gonna say triangle ABC. And then we want the short side, kind of go with the short side. So A and D looks like they go together. It looks like it goes ABC, DEF. That's congruent to triangle DEF. And then if those are congruent, then these two must be congruent. And same idea. Let's go like short side, right? So GHJ. And on here, that would look like this side. So KLM. So triangle, that's my bad triangle, GHJ is congruent to triangle KLM. That's the idea.